In this video, we're going to take a look at a specific learning target, and this learning target is I can name the solution or solutions of a system given the equations. So let's take a look at, so what you need to know. When you're given two equations, you can graph those two equations to see what type of solution you have. So the types of solutions that you're looking at, you might have two lines that end up intersecting one another. So they cross, and that cross, or where they cross, is your solution. And that's going to be a point on the coordinate plane, like an x comma y point. When you're looking at your actual equations, they're going to have different slopes and different y-intercepts. When you have two lines that never cross, that's when you have a situation where there's no solution because the lines are parallel, and those have the same slope or different y-intercepts. And then lastly, you have a situation here where the two lines are overlapping. Basically, they're the same line. So here you have an infinite number of solutions. So when given two equations, you're going to have one of these three scenarios. Either where they cross, where you have an actual solution, where they never cross, that would be no solutions, and when they're actually the same line and they completely overlap, and that's infinite number of solutions. When you're given two equations, you are going to be given equations in either usually standard form is going to be one of the types, that's your ax plus by equals c. If you'll remember, when we have standard form, the best way to graph that is by finding your x and y intercepts. So for the x-intercept, we plug 0 in for y, and then for your y-intercept, we plug in 0 for x. Your second form that we often see when given an equation is slope-intercept form, and that's y equals mx plus b. Here we graph using the slope and the y-intercept. Remember that your m is your slope or your rise over run, and that b is your y-intercept. Remember also when you're graphing slope-intercept form, you must graph your y-intercept first before you can use your slope. Okay, so here we're asked, what is the solution to the system of equations? So we need to graph the system so we know if our two lines cross, if they are parallel to one another, or if they're the same line, and we have infinite number of solutions. So when we're given two equations like this, we want to see what kind of form we're given. So here I'm in the form ax plus by equals c, or standard form. And when I'm in standard form, we have to find our intercepts. So for this first equation here, my green one, I've got my green pen out, we're going to find the x-intercept, and we're also going to find the y-intercept. So to find the x-intercept, we let y equal 0. So 3x plus 6 times 0 equals 24. And the second term just cancels because anything times 0 is just 0. So 3x equals 24. We divide both sides by 3, and x is going to equal 8. So there's my x-intercept. Now I do the same thing for my y-intercept, except I let x equal 0. So same equation, I go back to that same equation they gave me. I plug in 0 for x. Now that term cancels, and I'm left with 6y equals 24. We divide both sides by, not by 6y, just by 6. And my answer for my y-intercept is going to be 4. Okay, so I can go ahead and graph. Here you can see I graphed my x-intercept. That's where it crosses the x-axis, is at 8. And then my y would be at 4. And then I just draw in my line between those 2 points. So now that we did that for our green, or our first equation, I'm going to go ahead and do the same thing for the second equation. So to find my x-intercept, we let y equal 0. So that term cancels. 6x equals 6. Divide both sides by 6, and x is just going to equal 1. And then to find my y-intercept, we let x equal 0, so 6 times 0 minus 2y equals 6. My first term now cancels. And negative 2y, to undo multiplication, we divide both sides by negative 2, and y is going to be negative 3. So now that I have those 2 points, I can go ahead and plot my 2 intercepts. So x was equal to 1, and then y was equal to negative 3. We can go ahead and graph that line. Now we're trying to find the solution, okay? So that's the solution is where the 2 lines intersect. So in this case, you can see right here where they intersect, that point is at, we're using an xy, so over 2 and up 3. So my solution to number 1 is 2, 3. Okay, so now's a great time to go ahead and pause and try this problem and then come back and check here in a second. Notice that the problem here asks, what is the solution to the system of equations? So same question as before. We want to, after taking a look at our 2 equations, we can see that these are both written in slope-intercept form. So slope-intercept, we want our m, or our slope, and our b, or our y-intercept, for both equations. So for my first equation, or my green equation up here, my slope, or my m value, is negative 2 over 3, and then my b, or my y-intercept, is at 6. So what this would look like, I would go ahead and graph my y-intercept first. We always begin with b, and then my slope is down 2 over 3. So I would go ahead and count down 2 over 1, 2, 3. There's my slope, and I can draw in my line. And then I'm going to go ahead and do the same thing for that second equation, but this time my slope is going to be 1/2, and then my b value, or that y-intercept, is at negative 1. So when I go ahead and graph my y-intercept first, and then apply my slope, this time it was a positive, so am I going up 1 and over 2, draw that line in, and we can see where those 2 lines cross, or where they intersect. It's right here, and that would be over 6 in the x direction and up 2. So the solution for number 2 is 6, 2. All right, if you still need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.